So what we have to determine before we're going to bore our engine that we have over here in the boring bar is we have to determine what our size of our piston is and what size bore we want to finish at, so we can set our cutter that we're going to put in the boring bar to the correct size. Now in measuring piston, we want to measure, and this manufacturer wants us to measure about 200 thou below the skirt here. So somewhere in there, we usually want to go between 200 thou in there and 500 thou. Somewhere around there, so we get the piston dimension right. So when we measure this piston, we come up with a measurement, and I write my measurements down. I got them here. They're a little hard to see in the size that comes into the camera, but we write that measurement down. Now a piston, when it's designed, we have to know that they're not perfectly round. The pistons are what we call camground. So this piston is actually wider this way than it is this way, because of the bulk of material that's sitting in here for our pin bosses. As that starts heating up from combustion and friction in the engine, it's going to expand. And because there's more material here than here, it will expand farther this way than it will towards the skirt. So they can grind the piston, so it's actually ground in an oval or machined in an oval. And then what happens when this heats up in the cylinder and comes to its proper dimension, theoretically it'll be perfectly round. The engineers have figured out the expansion rate of the material they're using in the piston, and theoretically it will be perfectly round and it will expand some. They also will give us instructions, and we have instructions here for this piston, and it tells us what we want our bore setting at. With experience comes, do we want to go more or less than the manufacturer wants? In the application that this engine is going to go and do, it's going in a race vehicle, and the racing is going to be fairly strenuous on it. We want to open this clearance up. They're asking us to go 5 thou clearance, and we're going to go 6 to 6.5 on this. We're going to open up a little bit, and it tells you in the instructions in here that under extreme conditions you go 6 thou, and more than that you may want to open your dimension up. From experience, we know that these engines will run so hot that we want to make sure that we have enough clearance in there. So we mic the piston here, and we determine the dimension. The dimension I got on this piston is 4-inch, 26.5 thou. So what I'll do is I want to set my cutter for my boring bar, and we're going to show you how we put this in the boring bar. I want to set this cutter so that I can end up with somewhere around about 3.5 to 4 thou. I'm going to shoot for that 5 thou clearance, and when I hone it, I'll hone it to make sure that I take a little farther than the 5, and I'll get up to my 6 or my 6.5, so I got a little play area when I'm doing my final machining on here. So I'm going to set this tool, and on here I can set what I want it to, so I'm going to set it at 4-inch 28. Now that should bore this pretty close to 4-inch 28, 27.5. These tools have been around for years. This machine is older than all of us, so it still bores very correct. It's one of the better boring bars on the we could use. There's all sorts of fancy boring bars we have out there today, but this one seems to work real well. So we set our tool to bore the cylinder. The next thing we do is we set our dial indicator so we can get it set so we're at 0, and I'm at 0 there, which is telling me that this is set to 0 on here. So it is set to the exact size of this piston. So because it's set to the exact size of this piston, when I bore the cylinder and go in there to measure that, it's going to tell me what my clearance is, and I will show you that. It's going to say what our clearance is on there. And hopefully when I run this cutter through there, I'm going to end up that I'm going to have to hone somewhere around 3 thou to 3.5 thou out of this cylinder to get me to my 6, 6.5 that I want to be in. So I want to get all my cylinders within 1 or 2/10 of a thousandth of an inch between all of them. Then when I set my end gaps, all my clearances are right. This has got a fairly long skirt on this piston, very light piston though, so its expansion rate is going to be good. It won't rock in the bore as like some of our real short pistons do, so we can go a little more clearance on this piston, and we can keep it a little more stable in the bore. And by keeping it stable in the bore, we keep our ring seal a little better. The piston doesn't tend to walk down the bore. It comes straight down the bore as we fire the combustion gases against it. So we're going to look at all this, and remember that the top of this piston takes a lot of force, and when it gets forced down in the cylinder. And we're going to talk about our thrust sides of the piston, our major thrust side and our minor thrust side. We'll look at those later. We're going to look at that. We're going to figure out, you know, we got gases in this engine here that are going to be somewhere around the 3,500 psi that we'll have up in there on the explosion of the fuel we have in here. So you get 3,500 psi in the top of a piston that's 4-inch 30 thou. We're going to have a lot of force in the top of this piston, and we have to be able to keep that all in control with the connecting rods and everything else we're going to use. And as we assemble this engine, we'll go a little farther so you'll understand completely. But today we're going to look at an integral bore. We're going to look how we're going to bore that cylinder to fit this piston properly for the application we're going to use this engine for. Okay?